Hey everyone, today we will look at the anatomy of a Codename One application. Now, what does that actually mean? Well, a Codename One application has lots of files and directories and some conventions and some weird things, and some of these applications look different if you're creating an application in Eclipse. They look a bit different from the same application in NetBeans. And the same goes to IDEA, although IDEA and NetBeans are far more similar in terms of the way the plugin structures the application there. But either way, there are some files that aren't very clear for even people who have developed in Codename One for quite a while. Don't necessarily know and understand the underlying reason for some files that exist in the project. And here I'd like to give you both a bird's eye view in terms of how you can use it, but also how it works underneath, because I think that helps understand by pulling away the sort of the veil that the magician uses. In this case, Codename One sort of magically builds an application. The moment I expose how the cogwheels work, that might help you understand better how to use it and how to manipulate it in the best way possible. So before we begin, it's crucial that you have some basic Codename One experience, which means basically just creating and running a Hello World application, obviously installing Codename One. Because the Hello World video in the website is so good, I'm not going to try to replace it. So please go there, install Codename One on whichever IDE you prefer, and then we'll proceed from that point where I assume you ran your Hello World application. So this is an aptly named Hi CN1 World application. And I did the most basic, bare bones, native theme application, but it would work for pretty much any application. When you create it, it looks like this. I did build the application, so it will be consistent between the IDEs. Because Eclipse builds applications automatically, it had the build and dist directory, and neither NetBeans nor IDEA had these directories, and I wanted everything to look as similar as possible. In the case of NetBeans, the default view hides some of the actual files that exist within the IDE. So I'm shifted to the files mode. If you're just learning that IDE and chose to start using it, then you're by default in the projects mode, and some of the files that you see here are hidden. So if you select files from the view option, you will see something that's more similar to this view. And actually, as you can see, all of the IDs are very, very similar. They do differ in some things. You'll notice Eclipse has a lot of additional files, and those are mostly configuration files. They're not that important. Well, not for us at least. If you use Eclipse and you want to manipulate them, be wary of that, because we depend on things like the class path to remain consistent, and we depend on all sorts of configurations like that, so I'd suggest not manipulating them when possible. The same is true, by the way, for NetBeans and IDEA to one degree or another. You'll notice that the NB project exists both in NetBeans and in IDEA, and that is because the IDEA plugin that we wrote, we tried to make it as close as possible to the NetBeans projects, so it can literally open a NetBeans project, and that's very helpful for us, at least when we generate demos and things like that. It really helps. It does have an IML file, which is again a unique project file for IDEA, as well as the IDEA directory, both of which contain project internal files that don't really matter. But you'll notice that there is far more similar between all three IDEs then there is a difference, and that's because it's Codename One throughout, and the plugins are generally, as I said in the previous presentation, a very thin layer. So two of the directories that I'll start with, which are probably the easiest to just kick off the bat, are the build and dist directory. They're temporary directories that you can literally delete. You can just go to these directories and delete them, and they'll be recreated and rebuilt without a problem. The build directory is a temporary directory that contains the class files that get compiled and all sorts of temporary files that we need for the build process. So it's interesting to look in that and see what we build and how we build it, but it's not very useful for after the build because we don't use it once the build is finished. The dist directory contains the final jar file, and that is used in some IDEs for the simulator. In the case of NetBeans, the simulator uses it. In cases of Eclipse and IDEA, it's not used as much in the simulator. The simulator behaves a bit differently there because the build process for debug and run doesn't go through the ant.xml file in those IDEs, but it does for NetBeans. So, but building for the cloud always goes through this process. So the dist directory will include the jar file that we literally send to the cloud for the build process. And a lot of times this information is really useful. So one of the things that we do when people run into problems and they say, oh, there is this file that's, or the size of my application is too big, or there's this file that's causing problems with the build process. Well, one of the first steps is to look in the dist directory after you've sent the build and unzip the dist jar file. And looking inside it, looking at what was actually sent to the cloud. And you can see the files that literally reach our server and inspect them. So if there's the jar size is huge when you send it, the resulting application will be huge. I recently got a support query from a user who said, my app is 70 megabytes when I build it for iOS. Well, his jar file was pretty big to begin with, and ARM code is much larger than bytecode, and by a lot, and it all adds up, and that's why I reached that. And one of the basic tips is to look inside the dist directory, look at the jar, and see what is causing the big size issue. So the next file that's important is the CodeNameOneBuildClient.jar, and that's practically the first thing that we wrote in Codename One. And you'll notice the wrong spelling in the file name. It might not be initially obvious, but N is capitalized, which is something that we don't do because codename is one word and not two words. But when we started, it wasn't clear to us either. So it was capitalized and we sort of didn't notice, and that's it, it's gone, because people use it in case sensitive platforms, and you can't change case in a compatible way, so we're stuck with that forever. This file is essentially Codename One in a nutshell. It's the file that sends the jars to the cloud. It does a lot of other things. So for instance, unit testing, so it generates the sort of text file that we need internally to run the right unit tests in that mode, and it generates the GUI builder code, the source code for the new GUI builder. It's sort of jack of all trades, but generally it's the thing that sends the jar to the cloud build servers, and it does that through ant tasks, and I'll talk about them in a later slide. JavaSC.jar is really the thing that you work with most without really realizing it. So this is the simulator, literally. It's a port of Codename One to Swing to JavaSC. And it has some Java effects in it that we added to support things like a web browser and media and things like that just aren't available in plain Java. And that is a double-edged sword in some regards because JavaFX is so flaky. But we don't really have much of a choice if we want to simulate complex things like web browsers and media. So this essentially includes the skin functionality, but not the skins themselves, only the default iPhone skin. And it literally allows you to run the simulator and all the simulator menus and all the test recorder and everything. All of that is packaged into that one single file. And you can test that by literally running this line of code right here. Notice that it's important to do that from the project working directory, because it will look for the Codename One settings properties in that the main class name from there in order to actually launch the simulator. And it's essentially everything that you need is in there. And by the way, it's a fat jar, so it includes everything that's necessary. You can take that jar as is. And one of the things that we sometimes mention to people is that you can literally take that jar and package your own application without using the desktop build and things like that, because technically the desktop build is relatively simple. It's just that jar with some configuration and a special main file to configure it correctly. And you can get Codename One working on the desktop with very little effort if you look at the source code a bit and go through it. So, and here's one of the more interesting files that we have here. It's the Codename One settings. And the Codename One settings properties file is a standard properties file. Now, you can edit it directly. Sometimes it's a bit painful. So normally you should open the Codename One settings application in the right-click menu and use that. Almost all of the functionality in the Codename One settings properties file is mapped into this application, sometimes not in the most intuitive way, but usually in a more correct way. However, even if you use that application for everything, which I would recommend because it saves you from a lot of error-prone mistakes like escaping incorrectly and things like of that type, of that nature, it's still recommended that you look within the file occasionally to verify that the settings that you've applied are indeed there, and it sometimes gives you a better bird's eye view of everything, because the Codename One settings application sometimes hides information that might be relevant for ease of use, but you might want the ability to search within the entire configuration of your application, and that's where looking at the property file itself is useful. Now, I've snipped it here a bit because I don't want to go into all of the attributes that we support, because there's a lot of them. But you get the general drift that we overused the Codename One prefix for one. But another valuable thing here is that we can configure literally everything from here. And that includes the signing details, and you'll notice the app ID entry at the bottom that represents how to sign the specific application. Obviously package name, main class name, or display name, everything is configured within here. One thing that's also very important is the CodeNameOne.org value. Everything that's prefixed with CodeNameOne.org is a build hint. Now, this is sometimes confusing to new Codename One users, because the first thing you'd think is, isn't everything a build hint? Well, not exactly. Most of these settings are either hard-coded or not even relevant to the server, but rather done locally in the client or in one way or another. So a build hint is something that we mostly ignore in the client, and then provide the means to send it directly all the way to the build server, not just it sort of passes through the cloud server and goes directly to the build server that can query for that build hint. So obviously you can't make up any build hint willy-nilly, but the thing is that we as Codename One can expose one for you relatively easily. That means that when we build a feature into Codename One, so for instance, we want to expose a new capability in the Android port that's very specific to Android and that a specific customer asked us for. And we don't want to expose it to everyone. So we can say to that customer, oh, you add that build hint and type it like that. And within the Android build code, we can query for that build hint and do that thing only for that particular customer without saying, oh, this is for customer X. We literally code everything to the build hints. And that's really, really useful for us, and because it allows us to provide new features in a very agile way and change Codename One itself really quickly without impacting everyone, and also offering a lot of choice. So we can just push out a feature and someone can use it or not use it accordingly, and we don't need to get into the entire process in the middle. We don't need to build UI into the Codename One settings. We don't need to do a lot of things to expose functionality like that. So it's a very valuable feature. Now, the next file that's really important is the build.xml, which is essentially the thing that operates everything. And I wanted to start with the file I mentioned earlier, the CodeNameOneBuildClient.jar. And you'll notice it featuring prominently here. I've snipped a lot of the code. There's several task defs related to that, and the whole build for iOS device target is much larger. I just cut out lines completely to focus on these specific lines. So you'll get a sense of it, but if you want to really dig into it, open the build.xml of any project, Codename One project that you have, and look for these lines, and you'll see the rest of them because there's quite a few. So at first you can see a task def, which essentially imports the jar and says, okay, I want to use this specific class to implement that tag. And later on, if you look at the actual target for build for iOS device, which happens when you right click the project and say build for iOS device, naturally, in that case, we use that specific tag, and we can actually it actually calls the class from within the Codename One build client jar. And this is literally the code that sends the jar to the cloud, to our build server, and passes in all of the various values. There's lots of other values. I just snipped them out for simplicity, but you'll notice the package name, main name, and the target type obviously are all passed in. And this is very valuable because you'll also notice that the target definition has lots of dependencies like copying iOS override and all sorts of other things like that we do as part of the build process to make it simpler. Now, you can hack into that by adding things to be done before or after a build is sent. And that's a very powerful thing to do. You can literally automate everything within the build.xml to a very high level. And it's very, very useful. And we do that a lot for things like continuous integration, where we can send a synchronous build and get the result back. And that allows us to automate some tasks very beautifully. Not sure I'll have time to talk about that, but it's very helpful. So one of the things about the build.xml is that we sometimes need to update it. So a good example is when we came up with the new UWP port of Codename One for the Universal Windows platform. And we didn't want to replace the Windows build because that was still supported. So we needed to create a new build target. And that meant a new entry with a target like that in the build.xml. So how do we provide that? Well, we needed to replace the existing XML file. So if you look at the top of the XML file, we'll see there's a version number there. And our Codename One settings application and the system preferences from the IDE check that version number and check that it's up to date. And if it's not up to date, they will literally show you a dialog that says, do you want to update the build XML? And if you say yes, it will override and replace that file, including any change that you might have made to that build XML file. And that's why it might not be desired, and that's why we ask. But obviously, one of the side effects of that is that sometimes people aren't aware of that. So for instance, when we came up with the UWP port, people tried to send a build and it failed. And the reason it failed was because the build XML was out of date. So it's an important distinction to understand. I'll talk about the other distinctions and update later on. Another thing that's important to understand is that Eclipse build XML is very different from the NetBeans and IntelliJ build XML. And the reasons for that are due to the big conceptual differences between Eclipse and any other major Java IDE, and there isn't all that much we can do about it. There's just, if you look at the build XML, you'll still see the things that I mentioned are in Eclipse as well. So these portions are identical between all IDEs. But if you take the build XML from NetBeans from NetBeans project and try to stick it into Eclipse, it won't look pretty. It's a very different system of build there. So, but NB project is common between NetBeans and IDEA, and it is used in NetBeans internally because the IDE obviously uses it for supplementary XML files and preferences and things like that. The thing is that it's also used in IntelliJ because we try to keep the build as close as possible. So this is sometimes unintuitive. When people tried to hack the internals of the project, they found out that they needed to edit values also within the NB project file, which wasn't intuitive for people working in IDEA, as they assumed it was something remnant that wasn't important, but it is. The next thing on the agenda is the lib directory. Now, the lib directory serves two slightly different purposes, but they're still in the same category of libraries. So the first purpose is that it hosts our built-in libraries that aren't javasc.jar. In retrospect, javasc.jar should have been in the libs directory. We just didn't do that for some reason. But well, we're stuck with it forever now. And the lib directory includes the other jars. The javasc jar is the one that we use to run things. The libraries here are used only to compile. So in that sense, essentially, the lib is these two jars in zip, are really just during the compilation time, and the javasc.jar is just used during runtime. And in a sense, they're sort of the opposites of one another. CLDC11 is, well, it was a standard used during the J2ME era. And when we started, we limited the API to essentially that. And as we moved forward, we started supporting Java 5 and then Java 8. And the problem is that we named that jar in a particular way. And when I'll reach the update process, it might be clearer why we can't change it. And we're sort of stuck with that specific name. So one thing that's lesson learned here is never give files names that rely on a specific version of something. It would have been much nicer if we would have called it JAPI or something like that. It would have worked nicely, but we're stuck with that name. This file only contains stubs. It doesn't contain any code. So sometimes people use the IDE option to go to code, and they open a Java native code, a Java API code, and they see stubs, nothing else. And they say, wait, is Codename One even implemented? Even string doesn't have any methods in it. Well, yeah, it's implemented. This is just for compilation. It doesn't include any of the code because we don't need it for compilation. The implementation is completely different for every OS, so obviously we don't need to distribute that implementation. And obviously there's complexities involved, so we prefer just having stubs without any logic. The Codename One jar is just the jar from the Codename One project. It again allows us to compile. It does include the code, mostly because removing it is more of a pain than just keeping it in. And the last one is the Codename One SRC, which might not seem necessary, but it is there to provide you code completion with Java docs. Otherwise, when you press the dot key and want to get completion on a Codename One application, you will see just the name of the API without the Java doc description. And by having the source and having it in the class path, the IDEs know that when you click component and click and try to create an instance of component, they will show you the constructors and also show you the documentation for each constructor. And that's really important for usability, and that's why we have it here. The other use of the lib directory is for CN1 libs, which are Codename One extensions that you can either install by downloading them and placing them within the lib directory, or you can use the extension manager to install them. Now, one of the things that you do is you right click the project and say refresh refresh libs, and it refreshes and it essentially installs the CN1 libs that you have within the lib directory. The way that this works is through the build XML. The build XML has a refresh libs target, and that uses the AND task to essentially, again, Codename One, that Codename One jar, and Codename One Build Client.jar. So to avoid the confusion, it uses that to unzip the CN1 lib and places it into the impl directory that you see in front of you. Right now, you'll notice the impl directory is effectively empty. But when it's CN1 lib is unzipped, it's unzipped into these directories, which include all of the classes within the CN1 lib and the native code and the stubs, which are source code stubs, which is a bit of a complexity here that also again allows code completions with Javadoc for CN1 libs, which is something that jars never supported natively, which kind of sucked. So with CN1 libs that actually works. Normally you don't really need to know about this impl portion, but it's useful because sometimes you install a CN1 lib and it doesn't work, and you want to look, wait, where is the code for that? Where is at least the byte code for that? Where is it? So it's here. It's under the impl directory. You should be able to literally see it after you do the refresh libs, unless the CN1 lib is corrupted. All CN1 libs are just zip files, so you can unzip them and see that they're not corrupted and that they contain everything that you need. So that's, again, another useful thing. Last but not least, native directory. Now I'm going to skip that. I reached this, I'm going to skip that because we'll talk about native interfaces later on, and there's a lot to talk about. It isn't interesting unless we talk about native interfaces. It's just a directory you can literally ignore without talking about native interfaces. So I'm going to take a rain check on that. And that brings us to the final point, and that's the update process. This is one of the most complex issues that we sometimes face, and even long-time Codename One developers are still confused by the process that we have in place here, mostly because we have all of these different moving parts and each one of them updates separately. Now, I won't go into server updates and the other complexities, which I sometimes do, because there's a lot more than these three. But basically, I'm only talking about the current project. So the current project can be affected by three update processes. There are more. So the three are the build XML, which we've already talked about. So we're covered there. The build XML updates to the Codename One settings. The plugin update, and that's when you update the IDE plugin, and that has some implications. And the libs update. So let's start with the plugin update. You can update the plugin through the IDE. Every one of the IDEs that we support has its own process for updating the plugin. We don't issue plugin updates very often because it requires more work and it's not as necessary. For most things, we issue a plugin update when we need to update the GUI builder or the designer or other pieces like that. We don't need to update these with regular consistency because they're mostly stable. One file is impacted by a plugin update, and that's the CodeNameOneBuildClient.jar. Now, again, that's also a very stable piece of Codename One. It's core to Codename One, and its functionality doesn't change that much. Recently, we added to it support for the GUI builder code generation. So things like that sometimes require more frequent updates, and they require that you go into Codename One settings or do something in the project, but normally it just works. This update is seamless. It doesn't prompt you for anything. It doesn't ask. It just updates the Codename One build client because it's such a low-level implementation detail that asking for or notifying you of that update is sometimes would probably be more confusing than just doing the update. So that's one update. The build XML update we've discussed. It's to the Codename One settings. We're good there. And the third type of update is the libs update. Now that updates the four libraries that we've discussed: the JavaC.jar, the Codename One.jar, CLDC11.jar, and the Codename One SRC.jar. And usually when we when we announce an update every Friday, that's the piece we're updating because that's the most important thing. That's the API. That's what you're using. That's the simulator. That's literally all the pieces that you feel as Codename One. And these are updated on a very regular basis, once a week. Maybe less during the bootcamp, but generally once a week we produce an update for that. You can trigger an update manually to the latest version by going to Codename One settings, basic, select update client libs, the button on the bottom there, and it will fetch the latest version if there's a newer one available. But it also happens implicitly when you send a build to the cloud. So when you send a build to the cloud might say, wait, you have an older version of the libraries, better update. And that also happens implicitly and fetches the latest version. There is also a special case of sending a version build. A version build allows you to build to a specific version of Codename One. So for instance, if I want to maintain compatibility to version 3.6 of Codename One, I can select that and just say build for 3.6 and it will build for that specific version, and that's it. When I select the version 3.6, it will fetch the jars, the versions of these libraries that was the right one during 3.6, and that will allow me to simulate exactly as it would be after the build in the server, as it was back then, essentially. So that brings us to the end of the session, and I hope I didn't lose you along the way, because this is a bit technical, nitty-gritty, and it's not as sexy as some of the other subjects that we might be talking about, but I think it's important to understand, and it will help you when you start looking at the more interesting things down the road. So I hope you understand better how things work and got a bit of a glimpse behind the curtain at how these files look and how they are relevant. And if you have any questions, I'm always here as usual. And thank you so much for listening all the way through.